We're going to have a look at how to factorise cubics so that we can sketch them when we aren't given them in factorised form. So we're going to do that by first of all looking at how we would expand a cubic. I would probably start off by just expanding two of the factors first. So if we expand this, we're going to get x squared, x times minus 2 plus 3 times x, so that gives us a plus 1 single x, and then 3 times minus 2 is minus 6. We still have this factor at the end here, 2x plus 3, so now we just expand that, and we're going to basically look for our cubic term, x squared times 2x will give us 2x cubed, and then we're going to have x squared times 3. Then we have x times 2x, and we notice that that gives us another x squared term. So there are two ways of getting x squared terms, but only one way to get an x cubed. We'll then do x times 3, that gives us 3x. And then finally we need to do minus 6 times this, that gives us minus 12x and minus 18. We notice again that there are two x terms, but only one way of getting a constant at the end. We can now tidy this up. 2x cubed plus 5x squared plus minus 9x minus 18. So that is how we would expand a cubic, noticing that there's only one way to get a cubed term and only one way to get a constant term, but two ways to get x squared and linear terms. So what we're now going to do is we're going to run that process backwards, and we're going to use the hints we got there, particularly about this term and that term, in order to reverse engineer the factors. So let's say that we're told in the question that x minus 2 is a factor. Well, we know that if we divide this by x minus 2, a cubic divided by a linear term will give us a quadratic. So we're going to write down some quadratic. What I'm doing here is I'm just putting a little a there as a little placeholder. I don't know what the coefficient of my x squared term will be, or the coefficient of my x term, or indeed my constant at the end. But I can figure those out by reverse engineering this process. So I've just put the a, b and c there, so you know when I refer to a, I'm talking about the coefficient of x squared, b, the coefficient of x, and c, the constant in this quadratic. Okay, so working backwards, we know there's only one way that I can get an x cubed term. I must do, referring back to this one, my quadratic term times my linear term. Here, my linear term times my quadratic term. That must give me 2x cubed. I've only got one of those, so I must have two of these. Similarly, there's only one way to get the constant term. That was to do the two constant terms multiplied together. I have a minus 2 here. I need minus 18, so this must be a positive 9. That will give me minus 18. Now, in order to get this b coefficient, there are two ways to get either the x squared or the x term. So we can choose whichever one we want, and we'll figure out the way to get b. Let's look at x squared. Positive 5 is just a bit of a nicer number than minus 9, but we could do it with the minus 9. In fact, we probably will, just to check our answer. So, if we look at 5x squared, we know that we want to end up with 5x squared, so let's consider all of the ways of getting an x squared term by expanding these brackets. One way is to do x times bx. That would give me bx squared. Another way is to do minus 2 times 2x squared. minus 4 x squared. They've all got an x squared in them, so we can ignore the x squareds or cancel them out. Then we can just add 4 to both sides to tell us that b is 9, positive 9. We've factorised that, and now what we have here, this quadratic, should factorise. So we know that one of those factors was x minus 2. Another factor of this will be 2x and x. Factors of 9, 9 and 1. One of those multiplied by 2 is not going to give us a 9, so we'll try 3 and 3. They're both positive, so it's probably best just put this one in and check it works. 3 times 2 is 6x, 3 times x is 3x, they do add to give us 9. We've factorised it, and if we look, we've returned to the same factors we had. So if we're told one factor of a cubic, we can find the other factors by using this technique. We call this equating coefficients.